Israel's Iron Dome system, a mobile defensive network, successfully intercepts about 90% of incoming rockets. Despite an increase in the volume of rockets fired by Hamas from Gaza since their October 7th assault, this interception rate remains consistent. The Iron Dome, however, faces challenges, particularly in replenishing its interceptor missiles. Assisted by American manufacturing, the cost of these interceptors, named Tamir, varies between $40,000 and over $80,000 each. To address these limitations, Israel is advancing towards implementing a pioneering laser air defense system named Iron Beam. This system would mark Israel's first foray into such technology. The functionality of Iron Beam raises curiosity regarding its operational mechanism. Last year, Israel's Ministry of Defense greenlit the expansion of the Iron Beam project following its successful destruction of various targets, including rockets, mortars, drones, and anti-tank rounds in trials. As stated by Naftali Bennett, the prime minister at the time, the goal was to create a laser wall. Initially slated for operational readiness around 2025, the escalating conflict has expedited this timeline. But what is the Iron Beam's big advantage over the current system, the Iron Dome? Iron Beam's key advantage is unlimited ammunition. Laser shots are generated instantly, costing only a few dollars for the diesel fuel used in the electricity generator. Iron Beam stands out for its innovative use of mobile laser guns. These guns employ a network of highly reflective and efficiently cooled mirrors to concentrate light from LEDs into a focused beam. This design ensures the mirrors do not overheat. Remarkably, even after traveling 10 kilometers, the diameter of an Iron Beam laser remains as small as a coin. This level of precision is maintained in spite of potential distortions caused by wind and air temperature variations. But despite the impressive 100 kilowatt power of Iron Beam's lasers, the high expectations surrounding the system are overblown at the moment. Iron Beam's effective range is expected to be significantly less than that of the Tamir interceptors, which can engage targets from up to 75 kilometers away. According to Rafal, a state-owned Israeli company developing Iron Beam, its range extends to several miles. One of the limitations of the system is its sensitivity to weather conditions, as moisture and particles in the air like smoke can diminish laser energy. Another challenge for the Iron Beam is the required dwell time. To effectively neutralize a spinning rocket, the system's laser must maintain contact for several seconds to transfer sufficient energy to cause the rocket to disintegrate or detonate. This limitation means Iron Beam cannot single-handedly counter dense volleys of attacks. Therefore, it will operate in conjunction with the Iron Dome, which can launch rapid interceptor volleys. Iron Beam will also benefit from the Iron Dome's radar and computing network for targeting. The new system's lasers may be particularly effective against slower-moving attack drones which don't spin and have more fragile components like rotors, wing flaps, and guidance systems. These drones could be neutralized with shorter laser exposures. But what about Hamas or Hezbollah adapting to this new defense system? There are concerns that Hamas might adapt by covering their rockets with heat-resistant materials, so the countermeasure is currently under research. The initial cost for setting up Iron Beam's batteries is significant, although the exact figure hasn't been disclosed, but if it works, the Iron Beam, in terms of intercepting sufficient numbers of rockets, will justify its expense. Another potential use for this system was unveiled by Rafal, the Naval Iron Beam meant for installation on ships. The system is designed to emit 100 kilowatts out to several kilometers to protect vessels against drone swarms and anti-ship missiles. The naval version maintains the same external dimensions and can be configured to be integrated onto ship superstructures or in containerized modules to be embarked when needed. The Naval Iron Beam is planned to be operational within 4 to 5 years and first be fitted to the Israeli Navy's Reshef-class corvette. But it's not just Israel. The US is interested in this technological approach. In fact, within the massive supplemental funding request that the White House recently submitted to Congress includes $1.2 billion to support Israel's development of the Iron Beam high-energy laser. And if the technology works well for the Israelis, the US Army might want to buy the system for itself, according to the US government. Directed energy weapons offer advantages over traditional air and missile defense systems in that they are relatively inexpensive per shot and possess nearly unlimited magazines for engaging threats. So, under the Biden administration's funding proposal, $1.2 billion would be transferred to the Israeli government for the development of Iron Beam's directed energy capabilities to counter short-range rockets and mortars, like the ones being used by Hamas in the current conflict. In fact, the US military has its own fire protection capability high-energy laser prototype program, which is being overseen by the Army's Rapid Capabilities and Critical Technologies Office. The Israeli system is a slightly different approach technologically, so actually it's a nice complement because the US is kind of going down one path and Israel has gone down a slightly different one. There are not many specifics on how the US and the Israeli approach differ. It just has to do with how the laser beam is formed and aimed and its different power levels as well. The US is aiming to fortify both static and semi-permanent installations and is seeking laser technology that can defend against a range of threats such as cruise missiles, rockets, artillery, mortars, unmanned aerial systems, and both rotary and fixed-wing aircraft. In July, the U.S. Department of Defense awarded Lockheed Martin an agreement potentially worth $221 million. This contract involves the development, integration, manufacturing, testing, and delivery of prototype laser weapon systems for the Army's Rapid Capabilities and Critical Technologies Office. This project is scheduled for completion by October 2025. Lockheed Martin disclosed in October that the agreement entails the delivery of 2 prototypes of 300 kilowatt class laser weapon systems, with an option to supply 2 additional units. That's 3 times the power of the Iron Beam. Stay tuned for updates on these laser systems.